Hello everyone and welcome to vertical and horizontal stretches. So in this video I'll be talking about how to stretch functions either vertically or horizontally. So let's get started. So I'm going to start by inputting a function f of x. Let's say this function is the absolute value of x plus 4. So notice here our parent function is the absolute value of x, and I just added a vertical translation 4 units up. So everything is being moved 4 units up. So I want to add another function here. Let's say the function is g of x. And let's say g of x is the same as f of x. Let's say it's the absolute value of x plus 4. Now instead of writing it like this, I could just take this out and just replace it with f of x. That's saying the same thing, because g of x is equivalent to f of x. So now that we have two functions that are identical, I want to work on how I can stretch the function g of x. So when I think of vertical stretches, I want to think of multiplying the whole entire function. So everything's being on the outside. So let's say I wanted to multiply our f of x by 2. So let's see what happened here. So what I'm noticing here is everything kind of got shifted up and kind of more compressed inward. So let's analyze some points and see what's going on in this vertical stretch. So if we look at the point 0, 4 and we compare the vertexes here, it looks like all our y values are multiplied by 2 here. And that kind of makes sense because we're just multiplying our entire function by 2 here. Let's take a look at another point. Let's say the point 2, 6. And since we're multiplying all our y values by 2, you'd expect this point to be instead of at 2, 6, at 2, 12 now. Notice how our x is the same, but all we did was we changed our y. We just multiplied our y by 2. So that's basically all that's going on in vertical stretches, where you're just multiplying, you're keeping all the x values the same, but you're just multiplying our y values by 2. We could look at another point, for example. Let's say we wanted to take a look at the point minus 4, 8. We could expect this to be at minus 4, 16 now, because we're multiplying our y value by 2. So that'd be at minus 4, 16. So you can think of this entire expression here as we're just multiplying all our y values of f of x by 2. And I can even change this number. Let's say I wanted to do 3 instead. So notice, instead of being at 0, 4, we're going to be at 0, 12 because we're multiplying that y value by 2. So, I mean by 3, sorry. So there we go, we're at 0, 12. Maybe we could even analyze one more point here just to keep things safe. We're at 0.26, and 6 times 3, that is going to be at 218. It's going to be way up here. There we go, 218. So that's basically all there is to vertical stretches. So if your vertical stretch is greater than 1, in this case it is 3, you're basically going to be multiplying all your y values by that number. So what if your vertical stretch is less than 1? That's what I want to talk about here. Instead of being at 3, let's do 0.5. Let's see what happens if we do 0.5. Interesting. So what I'm seeing here is, let's just analyze some points here. So let's look at the point 0, 4 and 0, 2. So notice how their x values are kept the same, but the y values are halved. Well, that makes sense. All we're doing is we're multiplying all of our y values by 0.5. We're keeping the x the same, but we're multiplying everything by 0.5, or in other words, we're halving it. And let's look at some other points. Let's say we look at the point 2, 6. We expect, since we're multiplying all our y values by 0.5, it'd be at the point 2, 3. And that makes sense. We are at the point 2, 3 over here. So even if it's less than 1, you keep the same rule. You just multiply all the y values by whatever this number is. In this case, it's 0.5, so we're basically halving all our y values. So instead of minus 610, it'd be at minus 6.5. And we can even add a slider for this to even demonstrate further. So let's just add a slider k. So right now k is set to 1, so it's the same as our f of x. But if as k is greater than 1, the function is kind of getting more stretched vertically. It's more stretched vertically. And we could even increase this even more. But as we go below 1, we're going to be sort of getting compressed in like kind of the opposites, because all we're doing is we're halving all our y values. So hopefully vertical stretches make sense. Let's move on to some horizontal stretches now. So importantly, it's important to note that vertical stretches, we keep the x values the same, and we just change the y values. But it's going to be the opposite for horizontal stretches, because we're going to be changing the x values, but we're going to keep the y values the same. So it's kind of flip-flop, if you can remember that. So To work with horizontal stretches, all we have to do is we have to multiply inside the x. So instead of multiplying outside for vertical stretches, we're going to multiply inside with our x. So let's just say this is 2, for example. Okay, so let's analyze some points here. Let's say the point 2, 6 is now, let's say, since we're keeping the same y value, let's analyze the same. So it's at 1, 6 instead of 2, 6. So interesting, we just halved our x value. So instead of it being at 2, 6, it's now 1, 6. So this 2 here, what it did was it kept the y value the same, but it halved our x value because it's at 2. So let's analyze another point here. Let's say we want to analyze the point 4, 4, 8. So based on this relationship here, we should expect this point to be transformed into 2, 8, right? Because all we did was half our x value. And would you look at that, it is at 2, 8. So what this horizontal stretch basically does, it is if it's greater than 1, then you can think of whatever this number here is, we're dividing out our x value by that. So let's say we wanted to analyze the point minus 610, we're dividing our x value by 2. So in this case, it's at minus 610, it's going to be a minus 310. So it's kind of weird to think about. It's counterintuitive. Like, if this is greater than 1, why are you dividing? But that's kind of how it works. A good way you can think about this is we want to make whatever is inside of this the same as whatever is here. So let's take a look at this. So since our original function is at minus 6, we're going to have to make the inside of this function 3 in order to, because 2 times 3 is 6. So that's kind of a way you can think about it. So now that we got this covered, let's just try to think about what happens if we have values less than 1. So let's do 0.5. Let's see what happens here. So what I'm seeing is, let's analyze some points. So this is at the point 2, 6, and this is at the point 4, 6. So interesting, our x value is doubled. So instead of being at 2, it's now at 4, while keeping the same y. So what's basically happening here is it's kind of flip-flop. So instead of dividing by 2, now we're going to be multiplying by 2 because this is at 0.5 in this case, because that's basically saying it's 1/2. So instead of being at 2, 6, we're going to be at 4, 6. And we can even analyze some more points based on this relationship. So we can say, let's see, we want to analyze the point 4, 8. So instead of being at 4, 8, we'd expect it to be at 8, 8, because all we're doing is we're multiplying our x value by 2 here. So yeah. And a way you can determine the horizontal stretch here is you can just take this value right here and you can just divide 1 divided by that value. So it'd be look like this, 1 over 0.5. And that'd be 2, right? So you can take this number and multiply all your x values by 2 in this case. So that's how you determine the horizontal stretch. So let's say we have a horizontal stretch of 0.1. So that's pretty wide here. So we're going to do 1 divided by 0.1. And it's going to be 10. So our horizontal stretch is by 10. So that means we're going to be multiplying all of our x values by 10. So instead of being at 2, 6, it's going to be at 26 now. And would you look at that? 26. So that's one way you can determine the horizontal stretch if it's less than 1. But if it's greater than 1, you can do the exact same thing. Let's say this was 2. You can take 1 over 2. We're basically going to half all our x values. So it's going to be at 0.5. So we're going to do minus 2, 6. It's going to be at minus 1, 6. So hopefully that makes sense. Remember to use this rule. Just divide your this value, 1 divided by this value right here, to determine whether you're multiplying or dividing. So let's move on to some slides I have prepared. So when talking about vertical stretches, the vertical stretch in mathematical notation is going to be this. So you basically have your a value multiplied into your function f of x, where a is the vertical stretch by a factor of a. So that's how you write it out. And also important to note, if a is negative, then you're reflecting across the x-axis. So that's also what we learned in the reflections video. We basically had a negative number multiplied into our entire function, and we learned that that's just a reflection across the x-axis. We're flipping all over our y values. So let's move on to horizontal stretches and reflections. So in the mathematical words, it's your b is multiplied into your x. So instead of being on the outside, it's inside the x. So where b is the horizontal stretch by a factor of 1 over the absolute value of b. So that's just what we looked at in Desmos. To determine the horizontal stretch, you just divide 1 by b. And that's how you figure out how much you have to multiply your x values by. So if b is negative, then it is a reflection across the y-axis. Yep, that makes sense. We learned that in the reflections video. If you haven't already, watch that one. So if b is greater than 1, then it is a horizontal squash, but if b is less than 1, then it is a horizontal stretch. So if this b value inside here is greater than 1, that means you're going to be sort of compressing your function inward. But if b is less than 1, then you're kind of doing the opposite. You're stretching your function outward. So hopefully that makes sense, and watch the practice video. It will help a lot, and bye.